Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Problem 96. V-notch weir with a with apex 1.2 meters below the water surface of a 30 by 30 meter reservoir is located on one side of a vertical sided reservoir. A 600 millimeter diameter orifice is also located on the same side as the weir. If the length of the water surface cutting the weir is 1.5 meter, how far below the apex of the weir is the center of the orifice if they have the same discharges? The coefficients of discharge for the two outlets are the same. So to help analyze the situation, let's have the figure and check if the figure is correct. So we have a V-notch weir where the length of the water surface is 1.5 meters and the apex is 1.2 meters below that water surface. Then we have an orifice also of diameter 600 mm located let's call it h, small h meter below the apex of the weir. And the condition is the two outlets have the same discharges and they also have the same coefficient of discharge. So therefore, Q over the V naught sphere is equal to the discharge through the orifice. The discharge formula for the V naught sphere is 8 over 15 times the coefficient of discharge, square root of 2g, tangent of theta over 2, which is in this case half of 1.5.75 over 1.2. Then head over the orifice is, let's call it big H. So big H to the 5 halves. While the discharge through the orifice is kaotog, coefficient of discharge, area of orifice, square root of 2g times the head over the orifice, which is in this case small h plus 1.2. So that's it. And the head is denoted by H, big HO in this case. So Q of the V-notch weir is also Q of the orifice. That's the analysis or idea here. So substitute 8 over 15, coefficient of discharge, square root of 2g, tangent of theta over 2, head to the 5 halves, equals kaotog. So C area O square root of 2g times head over the orifice. So head over the orifice is small h plus 1.2. The head over the weir is 1.2. They have the same C, so we can cancel C. So 8 over 15, tangent of theta over 2, we also cancel square root of 2g. Then head to the 5 halves equals area of orifice square root of head over the orifice. Substituting 8 over 15 times 0.75 over 1.2, then 1.2 to the 5 halves equals pi point 3 square, pi radius square area O, then square root of HO. Simplifying, 1.8597 equals square root of HO. Square both sides. So HO equals 3.458 meters. And we equate that to small h plus 1.2. So from here, we can compute the value of h. So for the question, how far below the apex of the weir is the center of the orifice? So that's small h. So h therefore is equal to 2.258 meters. Problem 97. Water flows from one tank to an adjacent tank through a 50 millimeter diameter orifice. The, the head of water on one side of the orifice is 2.4 meters and on the other is 0.8 meters. Assuming coefficient of contraction of 0.62 and coefficient of velocity 0.95, determine the, for part 1, discharge in liters per second, and for part 2, the head loss in meters. Then redo the above problem if the tanks are closed and the airspace are subjected to 50 kilopascals and 20 kilopascals in the upstream and downstream sides of the orifice, respectively. So for the solution, discharge is Kautog, actual discharge, where the head H is for part 1, it is just 2.4 minus zero point 0.8, and C is C sub C times C sub V. So head is upstream head minus downstream head. It is equal to 2.4 minus zero point 0.8, so 1.6 meters. Substitute into the equation and multiply by 1000 to convert the discharge to liters per second. So 0.62 times 0.95, that is C, then pi 0.025 square. Area of orifice, square root of 19.62 times 1.6 times 1000. So Q is equal to 6.480 liters per second. For the head loss in meters, we have head loss equals 1 minus C sub V square times quantity H. And since we have already calculated H, so substitute head loss equals 1 minus 0.95 square times 1.6. So the head loss in meters is equal to 0.156 meters. For the second part, the head would be depth plus pressure head. So 2.4 plus 50 over 9.81 minus downstream head 0.8 plus 20 over 9.81, so it is 4.6581 meters. So Q equals 0.62 times 0.95 times pi 0.025 square, square root of 19.62 times 4.6581 times 1000. So Q is equal to 11.06 liters per second. Then for the head loss, it is quantity 1 minus 0.95 square times 4.6581. So head loss is equal to 0.4542 meter. So that's it for this problem.